Welcome to EduCasts, home of EduCasters. Modern applications and synthesis. The debate between the proponents of pure discovery and the advocates of explicit instruction has led constructively to a synthesis, a recognition that the most effective pedagogy is rarely all one thing or all another. Modern educational practice has largely settled on a hybrid approach, leveraging the power of discovery while mitigating its risks. The hybrid approach, guided discovery as the gold standard. Today, the consensus is that effective instruction utilizes what is often called guided discovery, or more formally, the explicit teaching of heuristics. This model advocates for a structured progression. 1. Direct instruction of foundations. The what. For true novices, the teacher directly and efficiently delivers essential background knowledge, terminology, and key concepts. This minimizes initial cognitive load and provides the necessary prior knowledge. 2. Explicit instruction of strategies. The how. The teacher models the process of discovery, the heuristics or thinking tools used by experts. This might involve showing students how to diagram a problem, how to identify variables, how to critically read a document, or how to generate a strong hypothesis. 3. The discovery task, the figure it out. Once equipped with the foundational knowledge and the process tools, students are engaged in a structured, open-ended task where they must discover the next principle for themselves. In this model, the teacher isn't just a guide. They are a metacognitive coach, explicitly teaching students how to engage in the process of productive struggle and discovery. This is the sweet spot where the efficiency of direct teaching meets the deep engagement of discovery. Technology's role in facilitating discovery. Technology has proven to be an indispensable ally in overcoming some of the practical hurdles of discovery learning. Virtual environments and simulations allow students to conduct complex, dangerous, or time-consuming experiments in a safe and rapid manner. Virtual labs. Students can discover the properties of chemical reactions or the mechanics of planetary motion without the safety risks, time constraints, or resource costs of a physical lab. They can change variables instantly and observe the consequences, vastly speeding up the hypothesis testing loop. Interactive data visualization. Tools that allow students to manipulate massive, authentic datasets, such as historical census information or climate statistics, enable them to discover macro-level trends and correlations that would be impossible to see by reading a textbook. The computer manages the cognitive load of data processing, freeing up the student's working memory for higher-order reasoning and interpretation, the actual act of discovery. Coding and gaming. Learning to code is in itself a sophisticated form of discovery learning. The coder encounters a problem, the code doesn't work, forms a hypothesis, I missed a semicolon, tests it, reruns the code, and diagnoses the error. Many educational games are designed as sophisticated discovery environments that embed mathematical or scientific principles into the core game mechanics, making discovery fun, repetitive, and intrinsically rewarding. Discovery learning in STEAM education. Today, discovery learning is the undisputed backbone of science, technology, engineering, arts, and mathematics (STEAM) education. The entire structure of modern STEAM is built around inquiry, design thinking, and the engineering process, all of which are iterative, discovery-driven cycles. Scientific discovery. Posing a question, designing an experiment, analyzing data, and formulating a conclusion. Engineering discovery. Identifying a user need, prototyping a solution, testing the prototype, discovering its flaws, and redesigning. In these fields, the content and the process are inseparable. You cannot learn to be a scientist by listening to lectures. You must learn by doing science, which is fundamentally a process of discovery. This focus on authentic disciplinary practice is Bruner's vision realized, teaching the student to think like an expert in the field. The future outlook. The ongoing refinement of discovery learning points toward a future where education focuses even more heavily on collaborative discovery and productive struggle. The future is less about individual isolated brilliance and more about team-based, interdisciplinary problem-solving. Educators are increasingly designing curricula where students must pool their individually discovered knowledge to solve a grand challenge, a process that mirrors the reality of modern workplaces, from tech startups to medical research labs. The ultimate takeaway from 60 years of theory and practice is that discovery learning is fundamentally about student empowerment. It teaches students that the greatest satisfaction lies not in having the answer, but in possessing the power to find it. It turns the learner into a participant in the great ongoing human project of creating knowledge. Discovery learning theory, catalyzed by the intellectual fire of Jerome Bruner, stands as a revolutionary challenge to passive education. It is an invitation to students to step into the role of the knowledge architect, historian, or scientist, rather than merely serving as a receptacle for pre-processed information. Tracing its lineage from Socratic dialogue and Dewey's pragmatism, the theory compels us to prioritize the structure of knowledge, not the sheer volume of facts, and to cultivate the intellectual potency that comes from testing one's own hypotheses. We have seen that when wielded skillfully as guided discovery, the approach delivers profound benefits in terms of retention, transfer, and the development of crucial metacognitive skills. However, we cannot ignore the stern but fair warnings from cognitive load theorists. Unguided discovery can lead to inefficiency and frustration, especially for novices who lack the necessary cognitive scaffolding. The modern, effective application of DL is therefore a sophisticated synthesis, utilizing direct instruction to build the foundation and technological tools to manage complexity, ensuring that the student's struggle is always productive and never overwhelming. The greatest lesson of discovery learning is that the joy of intellectual ownership, that powerful, unforgettable aha moment, is the most sustainable fuel for a lifetime of learning.